I'm Greg. I'm co-founder and chief exec at Undo, and I'm going to talk a little bit about continuous integration, and not just continuous integration, some of the kind of changes, cultural changes we've seen in software development. So, if you were to take a programmer back in, say, 1990, and like Austin Powers style, put them to sleep for 15 years, and then wake them up again, put them back into the world of programming, you'd see, I think they'd be okay. I think they'd be kind of at home. Now, things have moved on a bit. I guess sort of Java and .NET have happened, and the languages have evolved a bit. But the culture of how we develop software really hadn't changed very much. Lots of manual testing, releasing in a kind of waterfall kind of model, the way we develop software. And if you kind of look at the tooling, this Visual C++ was around in the early 90s, and other IDEs that we were all using. You wind forward, and they've rebranded to Visual Studio, and there are more pixels, and there are more features, but it's all kind of the same, right? I think if you imagine doing that more recently, taking a software developer 10 years ago, putting them to sleep and waking them up now, I think they would be like Austin Powers in the film, all at sea with the cultural change. Everyone's standing around whiteboards, moving Post-it notes around, right? And all this, agile development and test-driven development, and all these things that, maybe in 2007, people were doing these things. They certainly existed. People were doing them, but they were still quite rare, right? And I think over the last 10 years, now everyone is doing this stuff or some combination or something like it. And then, it would be completely mind blown with this notion of continuous delivery. And so a lot has changed. I think a lot of that actually has, I think, enabled this huge shift we've seen in computing, right? So most things as they change, be it species through evolution or technologies, you have these relatively long, stable periods punctuated by these sort of moments of quite quick change. And I think pretty clearly we've gone through one of those in technology, both in the kind of platforms, so moving from regularly delivered software through to software delivered through the web and through mobile, and the stuff behind it that's really allowed that to happen and allowed things like Uber, for example, to just really come from nowhere and be developed much more quickly and mostly pretty reliably. So, where are we on this slide? Yes, right. So we've moved forward. We're doing all this continuous integration, continuous delivery, what have you, test-driven development. We're testing in the cloud with elastic compute resource. And I think all this means that we're running thousands of times more tests, certainly orders of magnitude more tests, all the time than we used to. If you take a software project today, it's probably going to be running, several orders of magnitude more tests every hour, every day, than an equivalent size project 10 years ago. We were still kind of doing overnight testing, in fact, an awful lot of manual testing. And this has to be a good thing, obviously. More testing, better quality software, we can develop more quickly, like what's not to like. But of course, tests fail. I mean, if tests never fail, then they're not, what's the point of them, right? We wouldn't bother. And when you're doing all these, thousands of tests every hour or whatever it is, even quite a small failure rate can become really problematic. Now, with continuous integration, of course, it's a huge help, right? And most of the time now we have in our Jenkins or whatever we're using, and it says this test failed, and it says this is the commit that is associated with this test starting to fail, and a lot of the time you can just look at that and say, oh yeah, I forgot to, I got off by one error or whatever it is, and you can figure it out quite quickly and get up and running, and this is good. But I think the sort of 25% of harder cases, continuous integration really doesn't help you with. I'll get onto those in a minute. And what this means is, due to just the pressures that we all have, these different pressures, everybody would love, whenever there's a failure, like, focusing on that failure, understand it, root cause it, fix it before we do anything else, that would be great. It very seldom happens. I have had conversations with people who say they do that. I suppose I believe them. But the vast majority of people I speak to say that no, the reality of life is these failures come in. Like, this week's really busy because we've got some event that we're all focused on. Next week's going to be a lot easier, so we'll file that away in whatever bug repository tracking system we use, and next week we'll get to fix it. Of course, it never happens, right? Because next week it turns out something else happens, and we're too busy, and we can't do it. And what pretty much everybody gets is this growing backlog of tests in the test suite that fail, and nobody quite knows why. I mean, it's not completely unreasonable. Oh, sorry, I missed that one. Yeah. So, and it's particularly those intermittent failing tests that are the killer. Those tend to accumulate, right? And so what we tend to do, we kind of work around it. Most people, you exclude that test from the test suite because you know it's flaky, or you somehow mark it expected fail, so that you start, so at least you can spot new regressions. You don't just get swamped in this sea of failure all the time. But lurking in there's some nasty stuff, right? And so it's not completely unreasonable, because for the most part, we can kind of smell whether this is a serious thing or not. And often we can kind of think, yeah, I know what that test is doing, and I can see the way it's failing, and it's probably okay. It's probably, it could be a test infrastructure issue. It could be a bug in the test itself. It might be some really esoteric, rare set of circumstances that you can convince yourself are impossible, or at least sufficiently unlikely to happen. And there's the others where you can go, oh yeah, this is definitely bad, I need to fix this. But we all know that lurking in that growing backlog of test failures, there's some nasty stuff, right? And there's your security breach, or potential, or an outage, or just very unhappy. A lot of unhappiness is lurking in there waiting to come up. And there's nothing sadder, and I think this has happened to all of us, than when something blows up, big catastrophe, customer's really upset, whatever it is, we understand it, we nail it, and you say, yeah, you know what? There was a test lurking in our test suite that was showing this problem, and it started failing 6 months ago, and we didn't do anything about it. And now it would have been way, way easier to have dealt with it at that point. But it's really hard, right? Because the only way you can really know which are the test failures that really are going to hurt you is to understand what they're doing and root cause the problem. And when you've done that, you're basically 90% of the way to fixing it. So there are the times when continuous integration, when it's working well, continuous integration helps you do that. Test failure, this commit, fix it, move on, everyone's happy. But sometimes it can't help. You've got some mega commit, perhaps it's a merge or something, thousands and thousands of lines, some obscure test starts failing. Well, I don't know. The CI system just really hasn't helped me. Maybe the commit itself is fine, but there's something else that's now started to fail because there's some underlying issue somewhere else in the code. Again, CI can't help you. Or it's just a new test case. Right? So I've now got, again, the search space is just the entire code base, same as sort of pre-CI world. And if you do the math, as they say, you're doing thousands of times more tests, you're getting some, I don't know, tens or hundreds of times more failures than you used to have to deal with, and 25% of them are hard. And this cartoon I thought was quite liked. We've all been there. The real killer is these intermittent, non-deterministic issues like that cartoon, right? And hopefully I've got unit tests and they're quite nice and deterministic and it all works, but there are always these cases where the test just fails randomly, especially those kind of difficult, sort of stress tests and fuzz tests and things like that. It's like being able to just reproduce them is often really hard. So obviously I'm a little bit biased, but I think what we need around this is to capture those non-deterministic inputs so that we don't have to spend time reproducing that failure. That's really the goal of CI and automated testing, right? Is that we're almost there. Gone are the days, for the most part, where someone from the QA department says, hey, I did this and pressed that button and it crashed, and you try to reproduce it. Hopefully you've got some test that will do it for you. But we're not there with those non-deterministic failures. And things like live recorder that we have and other technologies are available to record these failures inside your CI and integrate it into your CI. So now it can get a lot better. So let me show you what that looks like. Come around some kind of, this is going to be tough because I've not got my screens mirrored. So I'm going to turn my back to you. So his Jenkins using its funky new Blue Ocean UI, but it's all standard stuff. And if I move this across, so here's some code, and I happen to know that if I just do a few more iterations here, and then commit it, and push. So all the good stuff happens, right? Jenkins notices that the repository's been updated and it starts to run my tests. Now we'll not, because of time, we'll not wait for that to go. Here's one I broke earlier. And so it's run this test pipeline, and a bunch of the tests have failed, and what we've configured it to do is rerun those tests with recording. And now, as an artifact of those failures, we have these recording files. And these recording files contain everything that the program did. And I can load them. I can click here and load that up. Switch to here. So here's my test code. This is a recording of what happened. I can play that forward. It's some sort of a assertion. I can step back. Now this is using undo and live recorder, so we have a reversible debug, which really helps. So assert 0, I've gone through assert 0, right, well, what's going on? Well, I can kind of see that I passed in number to this function cache calculate, which is supposed to return the square root. I passed in 255, and it returned 0. So clearly there's a bug in cache calculate. So let's step back. So now I can step back into cache calculate, see what it did. I can see it's returning from the cache. It's returning the ith entry in the cache. I here is 23. So let's have a look at what that is. So my cache is supposed to contain just a really simple cache mapping numbers onto their square roots. And sure enough, my cache contains bad data. It's corrupted. But that's OK. Let's just put a watch point on that. So watch point, sometimes called a data breakpoint. Usually you set that and run forward until it fails. This is a recording of the test failure, so I can just run back in time and just zoom back to when that data changes, and now I can look at what's going on. So this is where the corruption happened, and I can see I'm trying to write the square root in here of -1, and so its square root is garbage, and I've done that because I've got this loop at the top here, and I've kind of I've got a bounds check error. But the point is that commit I made was, of course, completely fine. I just did more iterations of the loop. There's no bug in the commit. It was somewhere else in my code. But having it there in the CI where I can just zoom in and see exactly what happened takes a huge amount of the guesswork away, and hopefully we can start to be on top of these growing list of test failures. So I have 1 minute left if there are any questions.
Oh, so you can carry on. We have
Oh, well, I've done that now. So, yeah, so let's go to questions. Yeah.
If you talk about letting tests keep failing, I think if you have a test that keeps failing, it's okay that the test fails. What is the point of having a test about?
Yeah, I mean, it's not okay, right? We want to fix these failing tests. My point is, in practice, it doesn't always happen as we would like it to. And in practice, these failures don't get fixed because we just don't have time. We have other competing pressures. Right?
How big do those recording files get, and so you absorb those in the order of certain megabytes?
Yeah.
How big is that test to do that?
It varies hugely, but typically you're talking kind of megabytes per second of recording. So they can get quite big, right? They can get on the order of gigabytes, but it's manageable. And of course, you only keep the ones around for failed tests, you don't have to keep all of them. Yeah.
Does it matter at all how you're running those tests? What tools you're using to run them?
No, I mean, in principle, the recording technologies are independent of the test framework. So the ones that I cited are, you could imagine some test framework that does include some kind of recording capability, but in this case, no, it's just a job to kind of stitch them together. Yeah, it's a different layer.
And are they say you've got more stable or more thread? Might get that idea. The data points are aligned, presumably how the threads line up,
Yeah.
so you might have something
Yeah.
all works.
Yeah, and I mean, that's a really useful, it's a key use case, because it's those multi-threaded tests often that can lead to those non-deterministic failures, and then can be really hard to debug. Yeah. But I mean, it's not only threading. I mean, we had one internally in Undo a while ago, and it only failed overnight. We couldn't reproduce it in the day. We kept running it in a loop and just would never fail. We found out it was because it was something to do with the date parsing thing, and if the time of day started with a 0, this proves that our developers never get in before 10. If the time of day started with the 0, that's what you needed to reproduce. Yeah.
In terms of things like, obviously unit tests, you should never be relying on anything external, but if you were doing more integration level tests and you were making calls out to external resources, like, and if it's things like file space or time of day or things like that,
Yeah.
would this be recording that state at that time?
Yeah. Yeah, absolutely. So it could be, reading off the network or whatever it's doing, and you record, what you do is you capture those non-deterministic inputs and sort of encapsulate them with the execution of the program. Now you've got this sort of thing, this recording file that you can now take different time, different place, different environment, but as far as that process that's been recorded is concerned, you replay, that gets replayed. Yeah.
Okay, one last question.
Oh, well, should we go further back here, because you've got it up. This one runs, if you're lucky, half speed. If you're less lucky, it might be sort of 3 or 4x slowdown. It does depend a lot on so it's one question.
I had a similar question.
Yeah.
I'm assuming you can run this in a manual test situation?
Oh, yeah,
Like
yeah,
so
yeah.
slow down by just like half.
Right, exactly. Yeah.
Okay,
Okay, thank you.